Hello student, in this video I am going to discuss about how we can measure categorical variables and numerical variables. From the previous video we can know or we know that what is categorical variables. Like here you can see in this chart, this is a date variable, this is customer ID, or this is transaction ID. These data are numerical, but these are not included in the analysis process, but these are important to index those data, or you can say to find those data, to search those data using these values. But we are talking about categorical variables here. Here you can see this annual income, or you can see gender values, or you can see children. This is numerical variable. Okay, here you can see marital status, that is also categorical variable because those are category, and this is also category. Though annual income can be become a numerical variable, but here in this chart you can see it is mentioned as a categorical variable. And city also we can see here again, these are categorical variable. But point is that for to be categorical variable, it is not only that values not only have to be string, it might be numerical also, but that defined as a category. But analyzing the categorical variable, we can know lots of things. Like here you can see uh, this is by counting the genders. If we use countif for a specific column or a specific cell or a specific row, we can get different data or analysis value. Suppose here you can see what is the gender count in this data set of, this is supermarket data. We are trying to gather the, or we are trying to analyze the information. Here the total number of male is lesser, total number of female is higher. And in this way we can make it as a gender percentage, means how much percentage exists in the data set for the male, and how much female exists in the data set as female. Again the number of count, okay, in different scale. Okay, scale is different. Okay, here you can see scale is different, and again gender percent in different scale. Okay, so using the categorical variable also we can analyze the data set in many way. But point is that we can suppose we can transform this categorical variable in numerical variables using some dummy values. Here dummy values for m is 1, m is replaced by 1, and all other values are replaced by 0 in that gender category. So doing that also we can convert that categorical variable into numerical variable, but and it will give the same result. Okay, it will give the same result. So why do we convert that categorical variable in numerical variable? Because sometimes summarizing the categorical variables appears to be overly tedious if the data set is very higher, and if we try to go through it manually, then it will become very tedious. So, and that is why those values can be converted into a numerical category by replacing with dummy variables. Okay. Next, we are going to describe how can we measure numerical variables? There are lots of new terminology you can found regarding these measures. Like first, we'll emphasis on mean. So what is mean? There is two type of mean. One is sample mean, another is population mean. Sample mean is that, or you can say x bar or mean of x is the mean for a specific set of or subset of the larger population. Okay, here you can see mean equal to summation of all the values of the samples 1 to n number of samples, total number of samples, and that summation will be divided by total number of samples or observation present in that sample set. Okay, and population mean will be denoted by mu. Okay, and basically this mean is nothing but the average of the values. And what is median? Median is nothing but the medial observation. Median is nothing but the medial observation. If the data sorted from smallest to largest and number of observation is odd, then medium literally middle observation. For example, if there is 9 observation, then the fifth smallest or fifth largest value will be the median. So here you can see that there is a first difference between mean and median. Okay, median is nothing but the medial observation. But here one point is very important, that is we need to first sort the numbers or sort the values of the samples. Then we can take the mid value. If it is odd, then the n plus 1 divided by 2 value will be the middle, and if it is even, then any one of the n by 2 plus 1 or n by 2 minus 1 position will be the median value. So here you can see one interesting point. Mean is this much, but median is this much. So there might be a vast difference because we are just taking the mid value. But here one inference is that from that sorted midpoint, that mean is this much. This means the salary of the basketball players having largest value of the salary is more than the medium. Are you getting? It means suppose this is the median value, then from that median value, if it is we are arranging it in increasing order, then after the median value they are having basketball players having more salary than the lowest income present in the previous part of the median. It means, again, if it is not clear, I am again here you can see, suppose we arrange this slot, arrange the salary values, then the mid value will be a different, but the mean value will be also different. But suppose in that position there is a median value, then people getting the salary in that slot will be lesser and people getting in that slot will be higher. So if the mean is higher, that means the summation of these values will be much more higher than the summation of these values. So that is the point of this inference between mean and median. So if the mean is low and the mean is lower than median, means mean reside in that slot, then we can say that summation of this part is higher than summation of this part. Okay, that is why mean comes in that side. So that is the inference from the mean and median. In general, we always know that what is range. Range is nothing but the minimum minus, or sorry, maximum minus minimum value. Okay, now we will discuss about what is variance, what is standard deviation, and what is mean absolute deviation. And there is also two different type of idea, that is skewness and kurtosis, and we will discuss this now. And again, there is one homework for you to know what is mode. Mode is different from mean and median also. And in this data set also, a mode is defined. But what is mode? Try to find out that. That is your homework. Now, first we know what is minimum and what is maximum value. That is mean of the whole values. Maximum is the whole values. Max of the whole values. But what is percentiles? Suppose here you can see, given a percentage such as 25%, what is the salary value of such that this percentage of salaries is below it? This type of question leads to percentiles, or we can say quartiles. Specifically, for any percentage P, try to note it or remember it. Specifically, for any percentage P, the Pth percentile is the value such that a percentage P of all values are less than it. Do you getting it? Suppose 25% is the percentile, or you can say 25 value is the percentile value, and such that percentage P of all values are less than it. Are you getting? The question was, what is the salary value such that the percentage of salaries below it? So people having salaries percentile 25%, that means 25 percentile people or 25 percentage people have less salary. Okay, similarly the first, second and third quartiles are the percentiles corresponding to the, if percentile value is 25%, if percentile value is 50%, if percentile value is 70%. We can check in the previous data set. So here Q1 quartiles, Q2, Q3. So here you can see 2, 3 quartiles. So people having less 25%, less than 25% salaries is 1. People getting less than 50% salary is 2. People having less than 75% salary, that is 3. And percentage of people, 1% of people has percentile 1. 0.05, or we can say 5% people have percentile 5, means they are getting that much amount of salary only, that much percentage of salary, total salary of, or we can say that much people, that much amount of money they are getting of the whole salary. Obviously here you can see, so people getting 99% or 99% salary means almost 99% will get the whole salary. Obviously that is the total value of the salary. So in that way you can understand, to determine how much percentage of people getting that much amount of salary can be determined using the percentile value. Okay, so that is about percentiles, quartiles, minimum, maximum. Okay, now we'll go through here variance. Okay, variance means it is essentially the average of the squared deviation from the mean, or you can see here the equation xi is the value for any ith value or sample value or observation value minus mean of that sample. So this S denotes that sample variance, but there is another term, that is population variance, and which is denoted by sigma squared. So this is squared value. So here you can see that value of the variance is squared value. That is why this value is very much higher, because that is squared value. Okay, so but here is one difference between sample variance and population variance. Why? Here you can see that for population variance we can take sigma square xi minus mean square divided by n. So why this value of n is different in case of sample variance, in case of population variance? But the whole equation is almost same, but difference is the denominator. Here this is n minus 1 for sample variance and this is n for population variance. This is also homework. Try to find out why this is n. And I am giving a clue. That is, there is a difference in the definition of sample and population also. Is that related with this value? Try to think. It might not be also. Okay? And next one is that standard deviation. Why we are trying to calculate standard deviation? Because we can see that variance value is the squared value, but the standard deviation is the square root of the equation 2.2. Equation 2.2 was this. So there is again two terms, population deviation and sample deviation. Population standard deviation is mentioned as or denoted by sigma, and this is denoted by, for sample deviation, is s, and both are squared root of the quantity of the variance, of the sample variance or of the population variance. So in that way we try to find out the standard deviation. So why we try to find that standard deviation? What is the interpretation or what is the significance of standard deviation? Here you can see in general we discuss or we try to analyze the data from data sets as a normal distribution function, and which will be discussed in module 3. Okay, about different type of distribution function that we can know, but that is deviation values related with the distribution also. So what is that mean? Suppose 68% of the observation within the standard deviation of the mean, it means that those values are more closer to the sample standard deviation. If 95% observation within 2 standard deviation of the mean is that is closer to s but twice as closer. Okay, if 99.7% is almost all of them are within 3 standard deviation, it means those are closer to sample standard deviation s but thrice as. Okay, it means that suppose if that is the mean of some data, then this much percent might be 68%, this much percent might be 95%, and this much percent might be 99 point something. So that is distance from s is plus minus thrice s, but that is here you can see this part and this part might be twice s, and this part might be plus minus from mean is s. So in that way, that inference can be built up from the values of standard deviation. Okay, so that is about standard deviation, and that is why it is very useful to find out the standard deviation. Here you can see variability is an important property of any numerical variable, and there are several measures of quantifying the amount of variability. Of these, standard deviation is by far most frequently quoted measure. It is measured in the same units as the variable. It has no long tradition. It has a long tradition, and at least for many data sets, it obeys the empirical rules discussed here. And these empirical rules gives a very specific meaning to the standard deviation, because then we know that how does data can be found around the mean, or how much that distributed around the mean. It is far from the mean or it is closer to the mean. Okay, here one point is that variability is the enemy. You can find this, and this is very much famous in operation management. If the distribution is higher, then it will become more problem. If distribution is closer to the mean, then it will be very good to understand the people. Otherwise, that those values become more unpredictable if it is more distance away from the mean. And there is next point is that mean absolute deviation. Mean absolute deviation equation, you can see here that there is no square or square root. That is simply xi minus mean divided by n. Okay. So here again you can see here, before leaving variance and standard deviation, you might ask why deviation from mean are squared in definition of variance. Why not this simple take the absolute deviation from the mean? For example, if mean is 100, two observations have values 95 by 105, then each has squared deviation of 25, but each has absolute deviation of 5. Wouldn't this latter value be more natural measure of variability? Intuitively, yes, it would be, but there is a long history of using squared deviation, and they have many attractive theoretical properties that are not shared by absolute deviation. Still, some analysts quote mean absolute deviation, another measure of variability. So, in this way also we can find, because if we square that term, then it will become 25. If we don't square that term, it will become 5 in this type of scenario. And then last, there is two terms. One, skewness, one is kurtosis. Now what is skewness? Skewness, you can see here, that value might be skewed to the right or skewed to the left. Suppose here you can see, if I draw the distribution function, suppose mean is this, and if I go through like that, it means this is skewed to the right. If I draw the same diagram like this way, then this is skewed to the left. Means this gives us the unsymmetry value of the data around the mean. So again, go to the text. Here you can see, if it is positive, means positively skewed, or there is skewness to the right, then we can say that these salaries due to large salary, and if it is left negatively skewed, then due to the less salary. It means this much people will having less salary, means number of people getting salary less is this much people, and which is bigger. then the getting larger salary. And if we say positively skewed, it means getting the larger salary. Having the people larger salary is much higher than having the people less salary. Okay, so again you can see here uh, it is positive when there is skewed to the right, it is negative when the skew is to the left, it is approximately zero when there is no skewness, means almost symmetric in both sides of the mean. Its magnitude increases as the degree of skewness increases. So if the skewness increases, then the degree of or the measuredness or the magnitude might increase, will increase. And next, there another term, that is kurtosis. Okay, so here you can see what kurtosis means. Actually, many times you find that here you can see uh, this number is related to the tails of the distribution, not its peak. But many times you will find that, or many people will discuss that as a pickedness, but that might be wrong. Higher kurtosis corresponds to the higher extremity of deviation, means that deviation will be much more higher if the kurtosis value is higher, not the configuration of data near the mean. Okay, again I am showing the diagram. Here you can see, okay, two diagram here. Okay, here this is peak value, this is more peak, this is middle peak, this is lower peak. People might discuss it as kurtosis value, but actually you can see the difference here. If the distribution is this way, that red part, then this has higher kurtosis value, but this is closer to the mean, then this is, or we can say that distribution, standard deviation distribution is, or you can say extremity of the deviation, that will be measured by kurtosis, and the lower the value of kurtosis, that extremity will be lower. Higher the value of kurtosis, then that extremity will be higher, and that is the way we try to define the value of kurtosis. So this is all about in today's video. We have discussed a lot of about how we can describe or how can we measure the categorical variables and numerical variables, and you might find different type of other name also different in different type of research thing, and there are some text also available in this book, how different tools are available to count or to evaluate those values. Okay, in Excel also there are lots of values already available, lots of tools already available, lots of functions already available, and please go through those things. It might be very useful for you. I have given just the definition and interpretation meaning of those values. Okay, try to go through this, and again in the next class we'll try to know about basically more what is time series data, what is outlier data, what is missing values. Okay, so this is all about in this video. If you have any doubt, please ask me in Google Classroom. Thank you.